We will hear now what happens when customers don't speak the same language, and Chris Simon is going to tell us. Have fun.
Thank you so much. Firstly, I just want to say thank you for your time and attention at this late stage in the conference. I'm sure everyone's heads are nearly exploding from all the amazing insights and knowledge sharing that's been going on for the last few days. Also, huge thanks to the conference organisers and the volunteers, AV crew, catering. It's been amazing. I really love this conference, and I hope you've all had a great time, as much as I have. My name is Chris. I'm from Australia. Yes, I've travelled a long way to get here, and I'm half asleep because it's 4 o'clock in the morning for me. But hopefully, with your help, we will sustain energy through the rest of the day. I'm going to be talking about when customers don't share a language. Not the language, not English or German, but domain language, which is obviously a topic that I think is of interest to this community. In some respects, this is a part 2, a sequel to a talk that I gave last year at KanDDDinsky and a few other conferences called Learning to Love Domain-Driven Design, A Tale of Two Products. In that talk, I explored 2 products that I was the CTO for as a startup. And the first one, I did not use domain-driven design because I did not know about it at the time. The second one I did, and I explored the contrasting experiences of those 2. But necessarily, it was quite high level. And I wanted to dive deeper into that second product and really give, I guess, a sense of the journey that we went on in exploring that domain, in learning about it, in implementing it, and evolving our implementation. So since we're talking about the domain, I'm not going to talk about technocratic things, not going to talk about services or deployments or any of that kind of stuff. We're just going to talk about domain models. So I have to give you some context about the domain, what landscape we were operating in. And it was the landscape of healthcare payments, particularly under various forms of insurance in Australia. So a typical interaction would be a healthcare professional would interact with a funding body, in some cases the Australian government, and would send through a request to say, sorry, the clicker is on a slight delay here. Maybe I need to stand closer. How much would you pay me to do some work for an individual? And the government would come back with a quote, say $50. The person would say, I did the work, and then they would get sent the money. Interestingly, the person receiving care, not really part of this interaction, although they might become part of it if they want to get extra services that are not covered by the government, they might pay out of pocket, or sometimes the healthcare worker might charge more than the government is willing to pay. So that's the thing that happens. Now that interaction, the Australian government and a general practitioner, a doctor, is just one of many types of interactions. We also have hospitals who are also requesting money from the government. We have private insurers, organisations that you can buy a policy from, and they will cover you for various injuries or accidents into various tiers. And they might cover services that the government doesn't fund, like physiotherapy or dentistry. But also they would cover some things that happen that you receive services in a hospital, private coverage in hospitals, or what they call elective surgery, things that the government doesn't think you really need but you might still want. And then there are other schemes. In Australia we have states within the country, and they sometimes fund different situations. So if you're injured at work, some states have a scheme that will pay for your recovery, or if you're injured on the roads, there's a tax as part of your vehicle registration that goes towards funding recovery from that road accident. And so obviously they will be funding things that happen at a hospital, sometimes from a primary care doctor, from a physiotherapist. And then there are other schemes for vaccination rollouts. Pharmacists might get involved in that. But as you can see, the landscape gets more complex. There are more and more of these interactions taking place. And then we get to the world of disability funding. Just people with a disability might be receiving care from a physiotherapist, or from a specialist disability services provider, or even from services that are not really things you would think of as healthcare related, like transportation, or maybe home modification. So it's the world of disability that we're going to focus in on for a little bit, because it's quite interesting and complex. And we have to go back in time a little bit to explain how did this used to work. So in the old days, the government used to provide a big chunk of money to a specialist disability services provider and say, could you please look after this person for the next year? Here's some money. We don't really want to know any more about it. And then they would send them the money, and once again, the person receiving care, the person with the disability, is not really involved in this interaction. They're off on the side. So I'm just pause for a moment to explain. I've used the iconography of a wheelchair. This is not meant to indicate that the experience of people with a disability is always the experience of a wheelchair user. People with a disability all have unique experiences. No two lived experiences are the same. So I only use this iconography because it's a commonly recognized one, but I think it's important to make that point. So to explain how this changed, we need to look at some disability theory. So under that model, where the government just provided cash, it was what was known as the medical model of disability. A doctor would assess someone and say, yes, you have a disability, there's something wrong with you. Now, that seems a bit outdated these days, hopefully, you agree with that. Over time, there evolved the charity model of disability. People would say, well, these people need help, let's raise some money, we'll provide them with the funds that they need. It's well-meaning, but it still leaves the person with the disability dependent on those sorts of funds and not necessarily in control of their lives. If the people running the charity decide not to do it anymore, they no longer have surety of access to the services that they need. Thankfully, beyond that, there evolved a thing called the social model of disability. And this is, I think, where it gets really interesting. The social model says disability is not a property of a person. It's a property of an interaction between a person and the society that they're living in. So what do I mean by that? I'll make it a bit more concrete with an example. I want everyone in the room here today who is fully sighted to imagine that you are transported into a world where everyone else can see in the dark. Do you think in this world we would have lighting in rooms or street lamps on roads? Probably not. Nobody else would need that. You would be considered disabled in this world without any change to your biology or your brain as it is today. So this example, I think, highlights that when we talk about disability, what we're talking about is the experience of living in a world that was not built for you. I'm not meaning to imply that social or external or environmental factors explain all disability experiences. Some disabilities carry experience of extreme pain or discomfort. But hopefully you can start to see that the medical model is incredibly wrong and in many ways quite offensive these days to say there's something wrong with you as a person, when in reality what it is that society is not accessible to you. Beyond the social model, there evolved the human rights model, which went on to say, not only do we recognize the social model as being a more appropriate way of understanding things, but you have the right to dismantle inequitable and inaccessible structures and recreate them in a way that gives you full access to the services and opportunities that everyone in society has. Now, I take the time to explain this because in Australia, the government, thankfully, changed their approach in line with this. And they started to make the people with a disability at the centre of the interaction. They had choice and control. They had budgets that they could spend on the services that they wanted from the service providers that they wanted to engage with. That meant that they could be sure that they were getting services that they needed, the quality that they needed. You can imagine in that old model, when they were out on the side and the government wasn't really paying much attention, that nobody knew how much money was left in the budget, and there was no recourse if the services were not what was really needed. So the interaction goes a little bit like this. The person asks for a quote. They're given one, and if they do agree to the quote and receive the services, then they tell the government to make the payment. Sometimes the government might send the money through the person, to the person who would then pass it on to the service provider. So this interaction is getting a little bit more complex compared to the other one. And if we go back to this broad landscape, sorry, went ahead. I want to make the point that every single one of these lines was not just a different conceptual interaction, it was a different process. It was a different paper form in many cases, or a different website, or a different phone number that you had to call. And in some cases, payment would not come through for months. And as a result, many service providers were declining to offer care to people who were funded under some of these schemes because it was not commercially sound for them to do so. So we saw this landscape and we thought, this is something we can help with. But when we looked into it and we learnt more about the scenario with the disability funding, we realised that's what we wanted to focus. So I set ourselves the initial mission to support the success of this new disability funding model by facilitating transparency, efficiency and ease of access to claiming and payments. The word claiming means that request for funds, a claim of the funds. But we have a problem here, commonly known as the chicken and egg problem in a two-sided market, or in some cases a three-sided market. We could not provide value to any one of these participants in this interaction unless enough participants on the other side of the interaction were already engaged with our system. So we had to find a way to break that chicken and egg problem. And in many respects, this interaction model that we just talked about was the key for us. Because at the start, there was a conversation that would set up the budgets. They would talk about the person's goals in life, whether they wanted to seek gainful employment or more social connection, and they would set up budgets against these goals. And they called it categories of support. And as part of setting that up, the person with a disability and their community of care now had the opportunity to manage their funds. So we set ourselves an initial goal to focus on this interaction between the service provider and the person with a disability, and to support these participants in this program for managing the use of their plans, the plans being the funding that was provided for a period of time against certain goals and outcomes. So with that context and background, we can now talk about the system design, because that's what we're here. We're software designers. I'm sure you're curious about the domain models and how we actually implemented this. So as inspiration, of course, we turn to the Blue Book, and this is an extract of the Blue Book towards the end talking about responsibility layers. This felt like something that would be helpful for us, and so we turned to it. And the idea is that you can break your system up into modules or bounded contexts, but try and have some structure even at that large scale. Don't just say, I've got 15 contexts. Organize them into layers where contexts at the higher layer depend on ones at the lower layer, so you can start to get a sense of the dependency chain between the contexts in the context map. And as a concrete example of this, Eric gives us this one, talking about different layers with different responsibilities and characteristics regarding their purposes and roles, the rate of change of the state, the kind of things that they do, and always the dependency flow is downwards. So we took this as inspiration, and we came up with our own responsibility layers. And as you'll see, we identified, in some cases, multiple contexts in each layer. But this high-level organizing principle was quite helpful for us to think about how we were going to build this. So we thought about an admin layer, capturing state reflecting the reality of the resources, things like plans and budgets. Operations layer, reflecting the actual claiming activity, the requests for money and the success or failure of those requests, and then a finance layer managing the actual movement of the funds. So with this in mind, we did some collaborative modeling with ourselves, because we were a startup, we didn't have any customers yet. But we came up with some ideas, and we sort of identified a couple of key contexts. A provisioning context in this admin layer to help provision new participants and service providers, a claiming context to receive the requests for payment, those claims, a plan tracking context. I do apologise, this click is, there's a slight delay here, and do I need to point it? There we go, maybe this is the thing. Plan tracking context, which would keep track of forecasts. How much money do I have left? How much money am I going to have at the end of my plan? And in the finance layer, a settlement context to handle the movement of the money, the settling of the payments, a reconciliation context to make sure that everything was happening properly, and a billing context to make sure that we would get paid, that our fees would be observing the rest of the system and then send fees based on what was happening. We selected event-driven architecture, and this works quite well with this notion of dependencies pointing downwards, because when we could think of it as events floating upwards. So the idea is that nothing in a lower layer should subscribe to events from a higher layer. And I think having some kind of organizing principle here is helpful in terms of avoiding the distributed big ball of mud effect that can sometimes happen when you allow all of your contexts to depend on each other too much. So one thing that's really critical with this is that even though we had this vision of this large-scale architecture, we didn't decide to wait until we had built the whole thing. We went small. We built a minimal model, a minimal implementation of just the two contexts that we needed to offer the value that we could see customers asking for in the short term, and it was this operations layer. Everything else we could do manually at launch, and this is classic startup thinking, right? You do what you can manually, and by organizing them into these layers, it helped us think about the rates of change in the layers. The admin layer is a low rate of change, so doing it manually in the early days is fine. The operations layer is a high rate of change, receiving many claims a day. It does need to be fully automated. So that allowed us to prioritize the implementation so that we could launch this product early and start getting feedback, and critically to iterate our models based on that feedback. So let's deep dive into that layer and these contexts that we're talking about that we decided to build first. So the interaction was a service provider's software their practice management system, would hit our API, submitting a request for payment, what we call a claim, that would flow through the claiming context, which would notify the participant in the scheme or their community of care to say, did they actually do this work? Are we okay to deduct this money from your plan? And if they said yes, we would process that against the budgets, but then also pass that through via an event to the plan tracking context, which would compute forecasts and so on, and would visualize those in an app with a graph showing the movement of the money against your budgets. So we were able to build and launch this in about a month. And I think this is a really interesting thing to focus on. You don't need to build the whole system to launch something to start getting feedback. And the value of operating in production and getting feedback rapidly is enormous. Just as a brief example, that graph, we built it going upwards, showing what had been spent. And one of the very first pieces of feedback we got was actually, we're more interested in it to go downwards and show us how much we have left. Obvious, right? But if you're not a person sitting in the seat using it, you might not think of that, and we certainly didn't. The other thing that launching quickly allowed us to do is to get to discover a whole scenario that we hadn't even contemplated, and none of the people we had spoken to had mentioned to us because they hadn't realized the consequences of what we were trying to do. And this was when a service provider who had not integrated with us was still sent a paper invoice to this person, maybe by email. And the person would say, well, I've got this paper invoice, but I want to deduct it off my plan because the whole point of your system is to show me how much money I've got left on my plan. If I can't register this invoice against the plan, then the data is inaccurate. So we had to contemplate this. It was not part of our original concept. We had not thought about this use case. We contemplated, well, we've got this claiming context, which kind of manages the budgets and the rules of whether that's a valid claim. Should we just allow the participant to enter the data into the app and send it into that claiming context? But there were issues with that. It wasn't quite the right shape. Because we were doing DDD, we were very sensitive to subtle differences in models and not colliding them too rapidly. And so we realized pretty quickly that the interactions involved in constructing this invoice, in doing the data entry, it was a multi-page form. There was temporary state involved. What we really had here was its own context. And so we built a new context off to the side called the pay invoice context. And this context was to support reporting the payment of an invoice by the participant. And so that handled the interaction with the app to allow the capturing of the data and would then flow through the rest of the thing. At that point, it just becomes like a regular invoice. We didn't care which direction it had come from, and it would flow through onto the plan tracking for forecasting and so on. So that was good until we realized that now this claiming context was kind of doing double duty. It had a responsibility of receiving the data from the service provider, processing the API request and everything involved with that, but also checking all the rules of the system to say whether or not this claim was valid or not, and the interaction with the participant to check whether it was a valid claim. And so this was an insight that we gained by actually doing it in production. We realized that we had overloaded the responsibilities of this context, and so we split it. So this is just to start with, to show you how we split it. This doesn't change. It's the same topology, same flow of the arrows. I've just rearranged them to highlight the difference. And what we did was we actually disconnected these contexts from that flow, and we split the claiming context into a separate one called the claims engine, which is where the rules were, and kept the processing of the API request in the claiming context, which turned into this. And once we sort of shuffled the boxes around and the lines around, it started to look quite sensible. You can imagine we have multiple channels for how the claims come in. Each of the contexts handles the unique varieties of interaction required to accept the claim data for those various channels, massage it into the correct format, pass it through to the engine for centralized processing of the rules, and then onto plan tracking for managing the rest of the budgets. Seemed very sensible. Just highlighting that's the responsibilities of the two new contexts. Then we had another scenario come up. Service providers who wanted to engage with us but couldn't convince their software developers to integrate with our APIs, and they said, can you build us an app so we can just type in the data into our app? And it was a different app to the one that the participants had, because that one was showing them their plans and so on, and it was just for them. But a service provider needed to have a list of all of their clients and to be able to submit an invoice against any client. So pretty quickly it became apparent that was a new input channel. So under the philosophy we had adopted, that became a new context, raising an invoice, which then flowed through to the claims engine again. And this gave us a lot of confidence that our general philosophy and idea for how we were going to organize these contexts was sound, because as new channels were identified, it was just a matter of building a new context. We didn't have to touch the other ones at all. It felt very safe. And then just make sure it flowed through to that central claims engine. So we're going to dive into that claims engine now, because I guess I've been talking about strategic architecture, high-level design of context and context maps. But it's also quite interesting to explore the tactical architecture, the aggregates and the sort of key concepts that we identified. And the claims engine, being the heart of the business rules around accepting or declining claims, was probably the most interesting. So a core concept obviously was a claim, request for payment, and the way we designed the process of reviewing the rules was to effectively use a chain of rules, which is kind of analogous to a strategy pattern, I guess. So we had a claim approver, which was the entry point, and it would construct a rules chain, and then there were a series of rules. And often what we found was that the rules would be comparing some data on the claim to some reference data of an entity associated with the claim. So in this case, there's a service provider valid rule, which was checking if the service provider entity associated with the claim, service provider being the healthcare worker, was valid at the point in time. The item code that the claim was for, which was what kind of service had been provided, is that valid for this participant, or it's the price correct under the current funding agreements. So there's a whole bunch of these rules. And structuring in this way was great. It allowed us to execute all of the rules, and if any of them failed, we could collect all the reasons for failure and pass them back in one go, rather than sort of having the first rule fail and then retrying, another rule fails, retry. So that was quite nice. The objects on the left that you can see with the stars are aggregates. The ones on the right, domain services. So stateless services that just manage the interaction between multiple aggregates, or encapsulated business rules that related to multiple aggregates. So the last rule there, the sufficient funds rule, was an interesting one, because that required looking at the participant and their budgets. And so we had to have a more complex structure for looking at these budgets and the transactions against the budgets, or as we modeled them as accounts. Because when we looked at this, we thought, this looks quite familiar. It looks like an accounting system. So we thought, well, this feels like a generic subdomain. We don't want to reinvent the wheel. Let's just go look at how accounting systems work, and we'll replicate their model. So we did that. We looked at accounts and a variety of structures that accounting systems use. So we designed this as a shared kernel because we thought this was very likely to be quite useful in the settlement context as well in the future. Maybe that was premature. It did end up sort of working out, but as you'll see, there was some complexity in building this. So to sort of explain how it worked, we would model an account with a balance. So an account to model the amount that we owed a given service provider, an account to model the funds remaining against a support category, so the budget allocated to a particular goal that a participant had, and an account to manage the amount of money that the funding program owed to the service provider. And then when a claim was approved, we would create what's called a journal, which would record a double book entry. This is classic double book entry. We debit one account, credit the other, and they have to match up. The balance of all the debits and credits must balance to zero, and then that affects the balance on the accounts that they relate to. When a claim is paid, there was another journal which would then transfer money from the program to the service provider, sending the balance of the money owing to the service provider back down to zero. Because these things didn't happen at the same time. We weren't sending money out the door immediately. We were accumulating throughout the day and then sending out the full amount that had been accumulated through the day. So at first we thought this was great. We learnt a lot from the accounting domain, a very well-established domain. It didn't require as much exploration, and it felt like a sound decision. But one of the things we realized was that we kind of came up against a very interesting phenomenon, which is DDD meets accounting. And I'm not sure I've seen many accounting systems that have tried to use some of the principles of DDD. And one of the principles of DDD that sort of conflicted with the way that these accounting systems are commonly implemented is the rule of aggregates and transactional consistency boundaries. So you can sort of wonder, where is the transactional consistency boundary in this interaction? Is it more important that the account and the list of entries against that account is consistent, that at any point in time, if you sum up all of the entries, it matches exactly to the account balance? Is that the most important boundary, or is the journal the most important boundary? I said before that it's an invariant that the debits and the credits must line up and add up to zero. And so we wrestled with this for a while because it wasn't really clear to us at first. It felt intuitively that the account, and having as all of its journal entries as children entities within that aggregate was not going to be performant because the number of journal entries could grow boundlessly over time, whereas within a single journal, the number of entries would be always finite and limited. So that was kind of the direction that we head in. But I found this curious because when you think about transactional consistency boundaries, database transactions, this scenario I'm talking about is kind of the canonical example that's often given. This Stack Overflow answer says, the highlighted bit down there, it says exactly this. A classical example is transferring money from one bank account to another. To do that, you have to first withdraw the amount from the source account and deposit it to the destination account. The operation has to succeed in full. If you stop halfway, the money will be lost, and that is very bad with capital V and capital B. Now, this is not a DDD-informed answer, because this is assuming that everything, the whole world must be transactionally consistent. But one of the nice things about DDD is through gaining insights into the domain, we can learn where are the real transactional consistency boundaries, which allows us to build more performant and scalable software systems. Now, the reason that this is interesting is because of concurrency. So if we roll back and think about, well, why is there guidance to design small aggregates? Why is the guidance to have small transactional consistency boundaries? I know there was another talk that I think was probably very related to this. I wasn't able to watch it, but apologies if I'm replicating some of the material from that talk. But if you can imagine two interactions in relation to potentially the same participant, but from different providers, or maybe the same provider for different participants, at some point, the same account is going to be interacted with. So we have these two concurrent interactions. There's a start of a transfer, we check the balance, which is part of how we approve the claim, to make sure there's the sufficient funds rule, you might recall. Then we update the balances by adding the journals and the entries, and then commit the transaction. So if we did all of this in one transaction, and then we did another one started in the middle, we would get a stale balance. So we might potentially approve a claim that we should not have approved. Or even if it was safe to approve it, when we commit the transaction, we might commit a stale balance because we've lost the update that was done in the previous one. Now, there are a number of potential solutions to this. The most common one being the do nothing, and the balances just end up being correct. This is the sort of naive, haven't really thought about this problem before kind of solution, which unfortunately does happen quite a lot in the wild. Then there's, thankfully, a lot of frameworks and ORMs give you concurrency detection, and what they typically recommend is that they'll fail the transaction for you. When the second one tries to commit, they'll detect that the data has been modified in the meantime. Sometimes there's optimistic, sometimes pessimistic concurrent detection, which is probably a bit too detailed to get into now. But the problem with that is if you just fail the second transaction, the user has a terrible experience because they didn't do anything wrong. It just was a quirk of timing that their transaction was rejected. So to resolve that, sometimes we say, well, we're not just going to fail it, we'll retry it. We might be using a message queue, which makes it easy to retry, or we might do an in-memory retry. Either way, I mean, it kind of improves things, but it's still not great. We might, the user might experience a delay while the retries are happening. And how often do you retry? What if you retry 5 times and it still fails, but it's just because you're operating very high load? It's still not great. So one thing that's interesting is when you event storm this scenario out, as it turns out, the intuition that the account and its journal entries are not really part of the same aggregate is sound. Because the truth is, in most accounting systems, the balance doesn't have to be transactionally consistent. Nobody is adding a journal to an accounting system and then immediately checking the balance. The timing that they check the balance is at the end of the month or at the end of the day. So, some slight, eventually consistent delays in the updating of the balance is totally fine. So this kind of event storm outcome is probably what you would model if you were using DDD to build an accounting system. But for us, that's not great. As I just articulated with those two concurrent streams, the balance check is not part of this. Most accounting systems don't have to decline the registering of a journal based on the presence of the balance. So, if we had approved it when the balance is stale due to another concurrent claim. So this is another way of stating the point that was illustrated by those two concurrent interaction models. So this is what we did. We implemented a pre-authorization step, kind of inspired by the way that credit card systems work, where there's sometimes a pre-authorization step. And so we would check the balance, we would record a pre-authorization within the account aggregate, and then if that was all okay, then the claim approver would detect that and approve the claim, and so the claim could become approved, which would then result in the journal being created, and then once it was journaled, then the accounts would be updated, and as a part of updating the balance, we would remove the pre-authorization. And look, it worked, it was fine, and it did have some advantages, which is that we could give the user feedback very early in this process. Because of the message mediation between the steps, we could give the user feedback very quickly, and the rest of the stuff could happen eventually consistently. Wouldn't matter if it was milliseconds or seconds or even minutes later. It didn't really affect things because the pre-authorization had been captured. So if a concurrent transaction came in, that would block it if it needed to. But in hindsight, many years later, I realized that there was probably a much simpler solution. And I think I had been led astray a little bit by the guidance to only modify one aggregate per transaction. And I realized this was crying out for a term that I thought I invented, but I realized later is there's some convergent evolution going on in the industry at the moment, a dynamic transactional consistency boundary. Remember a few slides ago I said that the issue was concurrency. So let's actually model out the concurrency. The participant's account is very low concurrency. One person is not processing many, many transactions at the same time, but the provider's account is high concurrency. So that is one that's introduces higher risk if we include it in the original transaction. So it's actually safe to combine multiple aggregates in the same transaction if you know for sure that under this domain they have low concurrency and contention of the same data. So I think what this helped me realize is that as much as the finance domain was a helpful model for us, it was kind of an example of premature generalization. In reality, the participant account and the provider account had very different requirements, very different roles to play in the overall transaction. And in particular, it's highlighted by this potential for a dynamic transactional consistency boundary, that potentially we should have modeled them actually as separate aggregates and not just as two instances of the same aggregate type. So I think this was kind of a lesson learnt in the dangers of premature generalization. You can start to think, oh, this looks just like that. I'm going to try and I'll use the same model and just try and massage it to work. There is value in gaining the deep insights that help you realize when two things are actually different things. And as you can see, there's some really concrete practical outcomes of that can have significant impact on performance and scalability and the ability to handle many, many concurrent transactions. So if you are interested in that, there was a talk yesterday, Sarah Pellegrini and Milan Savic are talking about, let's kill the aggregate, and the aggregate is dead. Very similar concept around dynamic transactional consistency boundaries in event sourcing systems. And also, I came across Jeremy Chassain at DDD Europe earlier this year, who's talking about the decider pattern and functional composition. So I think that just this year, I've noticed people are starting to challenge a little bit this traditional notion that you should only modify one aggregate in a transaction, and that maybe dynamic boundary based on the actual business operation that's happening is safe in some situations if you understand the reasons for the guidance. So that was our initial build. We built a couple of those contexts, and we launched it. We had customers and they were quite happy. We evolved and iterated it. I gave a few examples of that, and we felt we'd done some really deep domain modeling and refactoring and gaining great insights. But then there came a scenario that really, gave us a need to validate this concept in a larger scale, and that was the interaction with a new funding program. So we kind of felt like we'd tackled the chicken and egg problem. We now had a large number of service providers engaged with us, which was enough to convince a second funding program that they should connect with us. I should actually say it was the first funding program that directly engaged with us, because in the first one we were only engaging with the participants, not with the actual funding program. But in the second one, we were able to engage with a state-based funding source, and they allowed us to actually continue our mission by expanding the pool of service providers who are enabled to provide services with people with a disability. Because if you remember, our initial goal was our mission, was to support the success of the funding model, and indirectly by providing our services to another funding program, it would make our platform more attractive to more service providers. More service providers on our platform meant that there were more service providers who were enabled to provide services to people who are funded for the disability program. So there was a lot of positive feedback loops here that was going to enhance things and actually help us achieve our mission. Because what service providers wanted was more funding programs available to make it worth their while to engage with us. So let's get into what happened when we engaged with the second funding program. This was kind of the state of the system. with the internals a little bit sort of washed out there. And now we were interacting directly with the funding program, and they wanted their own API, and they wanted to have a bunch of interactions with us to do this. They wanted to onboard the known providers that they had, onboard the known participants, the people receiving the care. They wanted to be regularly updating the items that were available and the prices, and they wanted to receive payment reports. They actually wanted us to start sending the money on their behalf and to get reporting and reconciliation data associated with that. All very reasonable requests. And under our original context map, we had sort of already carved out some space to handle a lot of these things. So by this point, we had built out all of these contexts, the ones shaded in green there, over successive incremental releases and functional enhancements to our customer base, which lined up with the growth in the customer base so far. And then in order to support the next program that came along, we needed to add a new context to the admin layer to support the administration of the program data and the settlement layer, because they wanted us to start actually processing the payments. And then they did need some changes to the claims engine because they had their own rules and they needed some slight tweaks to the rules that we had already implemented. But this is where the title of the talk really comes from, because what we found very quickly is that their terminology was completely different. They did not share a domain language with the first program. So just a couple of key terms that I've been using a lot and haven't defined yet is a service provider, an organisation providing the supports, goods or services to support a participant in the program, and a claim, which is a claim for payment by a provider for providing a single support. Now, when we started talking to Program 2, they kind of really had some significantly different definitions for these exact same terms, and also some new terms that we did not have so far. So the service provider, for them, it was disconnected from the organisation potentially. If it was an individual, they wanted to track the actual doctor, the actual physiotherapist, because they might have a registration number and they wanted to know, is this person working across multiple clinics or what's going on there? Then for a claim, for them that was a funding block, the whole thing, not just an individual claim for payment. They separated out the billing provider, the person actually providing the tax invoice, and then they had an invoice which was a collection of line items for the separate services provided. They wanted to allow those things to be sort of collected into an invoice, which we hadn't supported so far. So we had a real sort of decision to make here. One option was to say, let's be guided by the language. It is what it is. We can't influence it. These two programs, they have different languages. That means they have different contexts. We really need to build two claims engines, one for one context and one for another, and allow them to have their own languages in there. Or option two, just try and harmonize the languages into a single language and just build one. Now, this was a hard decision to make. We didn't have enough data to really make what we felt confident was going to be the right decision. What we did have was a heuristic that if we went with option one, we were going to have to probably build a lot of context. Every customer that came along, we were going to have to build a new engine, which didn't seem very appetizing for the scalability of our business. But we knew with option two, there was massive risk there of cognitive load and all of the challenges that you have when you don't embrace the concept of a ubiquitous language. So what we decided to do, just purely pragmatically on the basis that if option one was the right answer, we didn't really have a sustainable business model, we went with option two. But I think even though it wasn't necessarily, it didn't feel right, being aware of the risks allowed us to keep a close eye on those risks as we were doing it. And we committed to monitoring the cognitive load of the teams and issues that arose as a result of it, and to make the commitment to change it if it turned out to be a problem. Now, as it turns out, it was quite advantageous. We came up with a new set of definitions, and even though it was only consistent within our organisation, it still massively helped communications between our developers, salespeople, support people, and so on. It didn't necessarily align with the customer's language in either case, but even having a consistent internal language was massively helpful, and in some respects potentially more helpful than having our internal teams have to constantly be switching the languages they were using, because we didn't have enough people to have an entire team dedicated to each funding program. So what we did is we went back and we refactored the code immediately. We made a commitment that we were not going to let stale terms exist in the code base, supported because we had done some pretty good test coverage. We actually did refactoring straight away, and I think that was a really important decision. I observed the impact of it almost immediately in terms of the quality of the conversations that were being had, and I thoroughly recommend not letting stale terminology live in your code base for too long. I know it's hard to sometimes prioritize it, but the payoff is immense. So to get back to some of the changes here, the other really quite interesting one is that this other program, they didn't care about the funds rule. They didn't have a budget limit at all. So all of that interesting conversation around accounts and limits and sufficient funds rules and transactional consistency boundaries was absolutely irrelevant for this funding program. So what we're going to do here, it was obviously a key part of the model so far, and maybe it should have been another hint that we really did have two separate contexts, but what we decided to do was to just put a Boolean on it, and if the Boolean was false, we would allow the balance to go negative. Now, was this a good idea or not? It helped us to launch quickly. It was, I suppose, a classic example of technical debt, but I'd like to refer back to Ward Cunningham's quote regarding technical debt. I loved Kevlin's talk yesterday about it, and I love his quote here. I'm never in favour of writing code poorly, but I am in favour of writing code to reflect your current understanding of a problem, even if that understanding is partial. And that's what we did. We acknowledged that our understanding was partial. We had to write the code that reflected our understanding with a commitment to refactor it as we gained insights and gained understanding. And I think this definition I really love because it directly contradicts the idea that technical debt is a shortcut or a hack. It's not a hack. You're writing the best code you possibly can with the understanding you have, acknowledging that you will gain understanding over time. And I think this quadrant from Martin Fowler is quite interesting, the reckless prudent column versus the deliberate and inadvertent. And we were trying to stay in the prudent column. The now we know how we should have done it was, I think, exemplified by that early example where we had to split that context into two. We didn't know at the start that that's what we needed, but we learnt it and we did it as soon as we learnt it. This example I just did now with the Boolean flag on the account, that's more of a we must ship now and deal with the consequences later. We knew it wasn't right, but we just kind of had to get going. Now, I'd love to say that that's the only technical debt that we had, but of course, as much as we had a lovely context map in our back end, and you would hope that we had nice modularity in our front end, who would venture to guess that we did or did not? You can probably guess where I'm going. Obviously, the front end was a giant big ball of mud. So we had a lovely back end and a big ball of mud front end, which was a real shame. And that is probably more an example of the what's layering, reckless side of technical debt, because it was really just a lack of understanding of what we needed to do to build a front end in a modular way aligned around domain boundaries. And I want to be really clear here, the front end was not spaghetti code in the traditional sense. Sorry, is that 5 or 10? That's 5, wow. So we actually did have, I think, good technical layering in the front end, but we hadn't split it on domain boundaries. So this is another lovely quote, Constantine and Jordan, structured design. This definition of coupling, I think, is wonderful. It's not a technical definition, but it's an operational definition. It sort of says, the degree of interdependence between modules can be operationalized as the probability that encoding, debugging, or modifying one module, a programmer will have to take into account something about another module. Now, I've bolded a few points there because there's a lot to unpack in this. So let's just unpack the first part, coding, debugging, or modifying one module. It highlights that coupling is a property of the code with respect to a particular change that's being made. So as an example, because we had nice technical layering in the front end, things like CSS changes were very easy to make, other kind of design changes were easy to make. So that was fine, basic UX changes. Similarly in the back end, because we had this nice context map, functional changes, the right type of functional changes were easy to make. A change to the rules, we could just do it in the claims engine. It felt wonderful. The system felt loosely coupled. It was great. Rules change, easy. UI process change, very hard. Because we didn't have nice domain-aligned boundaries in our front-end code, this made the front end feel technically coupled, and that's what made it feel like a big ball of mud. And in the back end, if we had a core model change, something that was shared around between the contexts, we found that change proliferating, and all of a sudden the back end felt very tightly coupled with respect to that change. So a core data model change was a problem. And we sort of identified that there was this heuristic. We had felt safe to share this data around the context because the data was immutable. But in reality, the problem was that the concept wasn't stable. The concept, we had not learned enough about this domain to know for sure that this concept was valid. So another way of framing this is that it's unsafe to share unstable concepts. The problem is you don't know which concepts are stable or unstable until you've been running the system for quite a long time. So there's another bold part in this quote that I think is important. A programmer will have to take into account something about another module. So the key part here is that it's a programmer having to take it into account. We have an architecture made up of technical components, and we have teams looking after those components. The teams are components in the architecture, in the socio-technical system, and the teams are the ones having to make the change. So their ability to make the change, their ability to take into account the various changes that are going to happen is a significant impact on the experience of coupling and the cost of coupling. And it's more than just the teams, it's the knowledge in their heads. So this kind of led me to this sort of belief that the knowledge in people's heads is a component of the socio-technical system. And this is kind of like a moment, but it's like you can now think about how do you manage the knowledge in people's heads just like it's another component of your system. How is this something that can help you in terms of onboarding and training and allowing developers to be involved in product discovery so that the knowledge in their heads aligns with the system and is now considered a key component of your overall socio-technical system. And the other thing that, to just go full circle here, that I really like is that this idea that coupling is not a property of the code, but an experience of the code being changed by a given team for a given change is very resonant for me with the social model of disability. There's nothing wrong with the code. The problem is that the code is being changed in a way that it was never meant to be changed. A person with a disability, there's nothing wrong with them. They're trying to live in a society that was not built for them. This is kind of a systems thinking pattern that we can start to recognize that crops up in socio-technical systems thinking. So I'm also going to refer to Vlad's book, forthcoming. I haven't read it. Obviously, it's not published yet, but from conversations with him and seeing his talks, I think these ideas that I was just exploring are explored in much greater depth in this book, so I do encourage you to check it out when it's available. So final phase, I know I'm getting very close to time, but I'll try to wrap up soon. We had this kind of, just to recap, large-scale interaction model, service providers asking for work, us evaluating the rules and saying, yes, everything's fine, or no, it's not, and letting the funding programs know what was going on. Now, the problem we had was when we got our third funding program, because we would do the rules, and then they did the rules as well, and sometimes they would get different answers. Not because we had misimplemented the rules, but because their reference data was sometimes out of sync with ours. And what was interesting is that they said, don't do any of the rules. Can you just not do the rules? Can you just ask us and we'll tell you whether the claim should be approved or not? And this was like, are you joking? We spent 4 years building a claims engine. But, you know, we listened to them and we went to our other funding programs and said, well, how would you feel about it if you took over the rules? And they said, actually, we always wanted to do the rules, but we didn't have budget to build a claims engine at the time, so we asked you guys to do it. And we realized that the domain that we were modeling was not reality. It was sort of informed by constraints that we had no visibility of. So we just kind of decided to bite the bullet and say, well, as it turns out, we were heading in completely the wrong direction. What was needed was not a rules engine, but a routing engine, something that would direct the claim to the appropriate decision-making entity, which may or may not even be us. So how did we do this? We moved that initial version of the system up into the corner, and we called it V1, and we started building a whole new system called V2, which was a routing engine. And so it would route any claims for those first funding programs off to our old V1 engine, which would do what it had been doing for years, and the new funding program integrated with the new engine. Obviously, we had service providers integrated with the old engine, but we would start getting new service providers integrated with the new engine. We gradually moved the service providers over to the new engine, and then gradually moved those funding programs over to the new engine as well, the new routing engine. And this took many years, but we started soon and we ran them in parallel so that we could continue to grow. And I think that even though there was a recognition that this was a technical change that needed to happen, by aligning the value of it with the business value of growing with these new customers, we were able to commit to doing it, convince people to fund it, and by finding this evolutionary change that allows us to operate in parallel and gradually migrate across, it made it a very effective approach. And kind of interestingly, we ended up with a combination of both option 1 and 2, because we did have adapters for these funding programs that were able to use the language of those funding programs, and then in the center we had a unified language. And interestingly, in relation to that unified language, calling back to the point about stability of concepts, by this time we now had a strong sense of what concepts were quite stable. So we could use them in our central layer and feel confident that it wasn't going to cause coupling issues. But we knew there were a lot of concepts that were unstable. So we decided to put them in a custom fields and just treat it as an opaque dictionary that we were just passing through to the decision maker. So we had no schema for that. It was just a blank slate. We obviously needed to have agreement with both parties, but the technical system didn't need to know about it. It was able to just pass it through, kind of like an envelope. So we had a unified ubiquitous language in one part of the payloads, program-specific language that we were schemaless for in another part. That was the stable part, that was the unstable part. And this idea of blending them but being explicit about which parts are stable and unstable was actually quite helpful. So to dive briefly into what this new V2 looked like, we would get the interactions into what we called invoicing. We didn't used to have claiming. And then we passed that through to a notification hub. It was all event-driven, so we could send webhooks out to the funding program. They would asynchronously come back to us, and then we would use the same notification hub to send notifications back out to the providers. So the notification hub had a data-driven subscription model. I don't want to dwell on exactly this. You can sort of see, you get a sense that it supported webhooks and a few other notification approaches, but the key thing here is the segregation of the domain logic in one context and the technocratic function in the other. The technocratic function could be quite generic, the domain logic was quite specific. And I think this separation is another heuristic that was quite helpful for us. So there's a lot of lessons learned in this, and I'm not going to recap all of them because it's the end of the day, the end of the conference. As I said at the start, your brains are already exploding. But I want to leave you with one lesson that Eric tried to teach us many years ago. A team committed to evolving order must fearlessly rethink the large-scale structure throughout the project lifecycle. It should not saddle itself with a structure conceived of early on when no one understood the domain or the requirements very well. Sounds a bit like the story I just told you, doesn't it? Unfortunately, that evolution means that your final structure will not be available at the start, and that means you will have to refactor to impose it as you go along. This can be expensive and difficult, but it is necessary. And I'd like to think this story is a proof point that Eric is a visionary, which is something we already knew. But we kind of lived this lesson. So just very briefly, I know I'm at time, my apologies. I've recently started a new meetup in Australia for domain-driven design. I know we're not in Australia, but we do live stream our meetups, so if you join and you see topics you're interested in, feel free to join the live stream. I know some people from Europe already are. And just separately, I've also got an open source project that was inspired by this experience called Contextive, and it's a dictionary that you can put in your repository and an IDE extension that will surface those definitions as you hover over terms in the code. And it's not tied to the language, the programming language, it just gives you the definitions. And there's a POC of a Slack bot that will actually surface those definitions in Slack if you use the terminology. Because one of the missions of this is to help with communication with people outside the team around the specifics of these complex domain languages. So if you're interested in that, check out the link. It's in VS Code at the moment, coming to more IDEs soon. And with that, my apologies for running over time, but I am done. Thank you very much.